Alright, we're going back to number 4 and 5, which are very similar to each other. We don't have to graph here at all. We're just going to look at our equation and figure out which transformations we're actually using here. So what we're going to do, we're going to compare our f of x to our g of x and see what changed in our equation, and then try to remember how did that change our graph. So in class, I always stress start inside of the parentheses. That's the easiest thing to start with. Here, what's inside the parentheses on the top, remember we can just write that as x cubed with our x inside parentheses. X is always alone inside the parentheses. Now we're doing minus 1. Inside the parentheses also always acts a little goofy. So this minus 1 you would think would move us negatively, but we're actually going to move positively because inside the parentheses acts goofy. So that's going to be a translation. Well, we can translate right 1. And then if we look outside the parentheses, we see we added a negative, which means we're going to reflect across, and since it's outside of the parentheses, we're going to reflect so it's reflecting kind of vertically, like the top goes to the bottom goes to the top. So that's actually reflecting across the x-axis. So those are our two transformations in number 4. Number 5 is a little bit more interesting because we have a little bit of different things going on. So if we look inside the parentheses, we don't really have parentheses. If we look inside the radical sign, we have some stuff going on. We have x plus 1. Again, since it's inside the parentheses, it acts a little bit goofy. So here we're going to translate, and here because it's positive, we're actually going to go to the left 1. Now we have this number on the outside. If we have a number on the outside, that's a vertical, and we often call that a vertical stretch. And then since our number is less than 1, we could also call it a compression, but let's just keep it as vertical stretch, but we have to say of what factor, which just means what number are we actually multiplying by. So it's a vertical stretch of factor 1/3. So if we think about this graphically, our parent function, which is that square root x, would move over to the left 1, and then it would look like it got squished vertically down to 1/3 of its size. So let's move on to number 6. I'll do 6, 7, and 8 in this video, and then move on to another video for 9 and so on. So let's move on to these where we are just doing some math on these functions. So notice inside the parentheses, it's going to tell us we want to do g minus h. So let's write down what we have for g, which is 3a plus 5. And then with these, let's always just overuse our parentheses to be safe. So we have minus, and then our h, which is 2a plus 3. So when we do this, now let's try to get rid of our parentheses. So we have 3a plus 5, and then minus. We need to distribute that minus sign, so we get 2a minus 3. So now we just need to combine like terms. So 3a and 2a are like terms, and this is one where we said we were all pretty comfortable with, so we can get 1a and then 5 and negative 3 are like terms, so then we just get plus 2. We can clean that up. We don't need that coefficient of 1 in front of the a, so we get a plus 2. If we do that same method over here, we should still use our parentheses, so that way we can just be extra sure we're doing everything correctly. Alright, and now we really don't need to distribute that positive like how we showed it on the other side, because positives don't change anything. And now we can combine like terms. There's nothing like a squared, and there's nothing like 4a, but negative 2 and negative 4 are both the same, so the same type of term, so we should get negative 6. So our final answer here is a squared plus 4a minus 6. And then our last one in this category would be number 8. And with that one, we have a different symbol here. So that open dot is actually our composition. And that means we are not multiplying, which might be on the test. We're not dividing, which might also be on the test. but we're composing here. So another way we can write that is g of h of t. Ooh, what is going on here? G of h of t. Okay. Alright, so let's plug in h inside the parentheses. We always start to the right. So we have t squared plus t inside the parentheses. We're actually plugging that into g. And g here is 2 times t. So we're replacing anything, any variable in g of t with our entire expression for h. So we do 2 times t squared plus t plus 5. So notice how we have that 2 and the 5 like we have up here. And we're replacing it with that t squared plus t. So now we just need to distribute that 2. So we get 2 times t squared plus 2t plus 5. There's nothing else to clean up here. So this is our final answer for number 8.